Hi, in this video, we will discuss the conjugate acid-base pair and the relative strengths of the acid and base in a conjugate pair. We have a conjugate acid-base pair because when a hydrogen ion is transferred from an acid to a base, a new acid and a new base are created. So an acid that donates a hydrogen ion to another substance creates a conjugate base. And a base that accepts a hydrogen ion from another substance creates a conjugate acid. For some examples, let's consider the reaction of these substances with water. First, we have hydrochloric acid. That is a strong acid, which means that it is very good at donating a hydrogen ion to another substance. So if we add that to water, water will act as a base. Remember, water is amphiprotic, meaning it can act as an acid or a base. So the hydrogen ion in hydrochloric will be given to water to produce a hydronium ion. So in water, we only have two hydrogen atoms. Now we have three. And water is neutral, and it accepted a hydrogen ion. So now the charge is positive one. Okay, for the other ion, that is the remainder of the hydrochloric acid. So the hydrogen is lost. Okay, therefore what remains is Cl. Now hydrochloric acid is neutral, so the charge for Cl is 0 minus positive 1 for the hydrogen ion, so that is negative 1. So in this case, the hydronium ion was produced from water, correct? Okay. And the chloride ion was produced from the hydrochloric acid. So therefore, we can say that water and hydronium ion is a conjugate pair. Conjugate pair where, since water is base, therefore the hydronium ion is an acid. In the same manner, hydrochloric acid and chloride is also a conjugate pair. Now, since hydrochloric acid is an acid, then we can conclude that chloride is a base. So, in each conjugate pair, we have an acid, and a base. An acid and a base. Okay, next example, we have here methyl. Okay, so the methyl anion. Okay, the methyl anion is a strong base. Okay, so it is very good at accepting a hydrogen ion. If we add that to water, then water will act as an acid. Okay, so since a base has the tendency to accept a hydrogen ion, one of these hydrogen atoms from water will be given to or will be accepted by the methyl anion. That is to produce methane. So in methyl, we have three hydrogen atoms. In methane, we now have four. Since methyl it has a charge of negative 1, and it accepted a hydrogen ion, so that is negative 1 plus positive 1, so the methane is neutral. That's why we don't see here a charge. Okay. Next, the remainder of water, since it lost a hydrogen ion or atom, is a hydroxide ion. Okay, so yes, methane again is produced. Methane is produced from methyl. Okay, so therefore, we have this conjugate pair. Okay, okay, hold on. Okay, conjugate pair. So capital CP for conjugate pair. Okay, where since methyl is a base, then methane is an acid. Okay, in the same manner, hydroxide was formed, okay, from water, so that is another conjugate pair. Since water is acting as an acid, then hydroxide must be a base. Okay, so again, in each conjugate pair, we have an acid and a base. In these exercises, we have to determine or identify the unknown or missing conjugate acid or conjugate base. Now, this should be easy because to determine a conjugate base from a conjugate acid, we simply remove a hydrogen ion. And to determine a conjugate acid from a conjugate base, we simply add a hydrogen ion. So first we have sulfuric acid. If this reacts with water, it will give away one of the hydrogen atoms. So therefore, we simply have to remove a hydrogen ion or atom. So now we have, if in sulfuric acid we have two hydrogen atoms, now we have only one. Okay, and then we copy SO4. For the charge of this hydrogen sulfate, well, sulfuric acid is neutral. If it loses a hydrogen ion or atom, so that is 0 minus -1, rather minus +1, so that is -1. Next, we have ammonia, and that is a base. If it reacts with water, that will accept a hydrogen ion. Okay, so we simply have to add a hydrogen ion. So we copy N, H. In ammonia, we have three hydrogen atoms. Now we have four. For the charge, ammonia is neutral. Okay, and if it accepts a hydrogen ion, so that is 0 plus +1. Therefore, the charge of ammonium is +1. Next, we have hydrofluoric acid. Okay, if it reacts with water, it will give away this hydrogen to water. So we simply have to remove a hydrogen ion. Okay, and what remains is F, correct? For the charge, hydrofluoric acid is neutral. So that is 0. Okay, if it loses a hydrogen ion, so 0 minus +1. So the charge of fluoride ion is negative or -1. Next, for base, we have methylamine. Okay. Again, remember in methylamine, it is the nitrogen that will accept a hydrogen ion. Sorry, just a hydrogen ion. Hydrogen ion. Okay. So we simply have to add a hydrogen ion. Okay, to the NH2. Okay, not to the CH3. Okay, so let's copy CH3. Again, the nitrogen will accept the hydrogen, so it will become NH3. Now, since methylamine is neutral, okay, the charge of this methyl ammonium is 0 plus +1 for the hydrogen ion. Okay, so that is positive. Okay, finally, we have acetic acid. Okay, remember in acetic acid, this COOH group is what we call the carboxylic acid group. And in a carboxylic acid group, this hydrogen will be given away to water. Okay, so therefore to get the conjugate base, we simply have to remove a hydrogen ion from the COOH. Okay, so let's copy CH3, then COO. So that is the acetate ion. Okay, for the charge, well, the acetic acid is neutral. If it loses a hydrogen ion, so the charge is now 0 minus +1, so that is negative. Now, if we compare the strengths of the acid and the base in a conjugate pair, they should be opposite. So, a stronger acid, okay, has a weaker conjugate base. And a weaker acid will produce a stronger conjugate base. For example, we have hydrochloric acid. This is a strong acid. If it reacts with water, this hydrogen will be given away to water to produce hydronium. Okay? And The other ion is the remainder of the hydrochloric acid, which is Cl. Since hydrochloric acid is initially neutral, or is neutral, okay, so the charge of the chloride ion is 0 minus positive 1 for the hydrogen ion, so that is negative. Okay, so hydrochloric acid again is a strong acid. Okay, since the chloride ion is produced from the hydrochloric acid, okay, we can say that the hydrochloric acid and the chloride ion produce a or form a conjugate pair. Okay, so since hydrochloric acid is a strong acid, therefore we can say that the chloride ion is a weak base. Okay, so strong acid, weak base. In the same manner, a stronger base has a weaker conjugate acid, and a weaker base will produce a stronger conjugate acid. Okay, for example, we have again we have here methyl. Okay, methyl is a strong base. Okay, that is a strong base. If it reacts with water, then it will accept one hydrogen ion. That is to produce methane. So since methyl has a charge of -1, if it accepts a hydrogen ion, so that is 0, rather -1 plus +1, okay, so the charge of CH4 is 0, so it is neutral. Okay, and the remainder of water, of course, is hydroxide ion. Okay, methane is produced from methyl. So therefore, these two substances form a conjugate pair. Since methyl is a strong base, we can say that methane is a weak acid. Okay, so again, in a conjugate pair, you can have a strong acid but weak base, or a strong base but weak acid. Now, in this table on the right, the strength of the conjugate acid is increasing as we go up the table. So again, we have here increasing acid strength. For the conjugate base, the strength is also increasing, but that is as we go down the table. So again, we have here increasing base strength, such that the conjugate, sorry, the sulfuric acid, hydrobromic acid, hydrochloric acid, and nitric acid, uh, which are considered strong acids, have the conjugate base hydrogen sulfate, bromide, chloride, and nitrate, which are considered weak bases. In the same manner, the hydroxide, hydrogen gas, and methane, which are considered weak acids, have the conjugate oxide, hydride, and methyl ion, which are considered strong bases. Now, when it comes to acid-base reactions, they tend to proceed from the stronger to the weaker member of a conjugate pair. So, for example, we have here sulfuric acid. That is a strong acid, right? Strong acid. Okay, if that is added to water, one of these hydrogen atoms will be given away to water to produce a hydronium ion. And the remainder of sulfuric acid is we now have one hydrogen, then we copy SO4. For the charge, well, sulfuric acid is neutral. If it loses a hydrogen ion, so the charge is now 0 minus +1, so that is -1. Now, hydrogen sulfate is produced from sulfuric acid. Therefore, these two substances form a conjugate pair. Okay, since again sulfuric acid is a strong acid, then hydrogen sulfate must be a weak base. Okay, for the direction of reaction, Okay, again, it has to proceed from stronger to weaker. Therefore, the actual reaction will proceed from left to right. Okay, uh, that is from sulfuric to hydrogen sulfate. In other words, there is higher tendency to produce hold on. There is high tendency for the sulfuric acid to produce hydrogen sulfate. Okay, next we have methane. That is a weak acid. If we add that to water, one of the hydrogen atoms will be given away to water to produce a hydronium ion. Now the remainder of methane is CH3. Okay, so methane is neutral, but it lost a hydrogen ion, so that is 0 minus positive 1. Therefore, the charge of methyl is negative 1. Now, methyl is produced from methane, right? So these two substances form a conjugate pair. Since methane is a weak acid, then methyl must be a strong base. Okay, again, since an acid-base reaction proceeds from a stronger to the weaker member, okay, so in reality, okay, this reaction will proceed from the right to the left, from the right to the left. Okay, because on the right side we have the strong base, and on the left side we have the weak acid. Therefore, there is higher tendency uh, for um, for the methyl to produce methane. And that's it. Thank you for watching.